Hi, I am back again today to talk to you about a couple more ways that we can describe solutions qualitatively. Quantitatively. What I want to do really quick is review a little bit what we talked about last time with solutions, and then get into discussing the other two ways that we can measure solutions. So as you can see from my screen here, see here how to present. One of the important things you need to know about solutions is the vocabulary associated with them. So it is very important that you know that a solution is made up of the solute, which is the item that is being dissolved, and the solvent. Usually the solvent is water. Every single calculation that we will do in our class, the solvent will be water, but there can be other substances that are solvents like carbon tetrachloride or benzene or something. Whatever, there can be other chemicals that make up the solvent. So again, the solute is what's dissolved into the solvent, and the two things added together make up the solution. The other thing that I wanted to just review real quick with you were those terms that we talked about, the saturated, unsaturated, and supersaturated solution. So remember that a saturated solution, just like a saturated fat, has as much solid or solute as can fit into the solution at a given temperature. And we, of course, know that if you heat a solution, as it gets warmer, you can dissolve more solid, which you can kind of see in this curve here, especially for the sugar, right? That as the temperature of your solution goes up, the amount of sugar that can be dissolved also increases. The same thing happens down here for salt, although it's a very, very small change, but you can dissolve a little bit more salt than you can water. A couple of things the other thing I guess that I want you to notice, obviously, is that there are different curves or different amounts of solute that can be dissolved. So the identity of a solute does help you understand how much can be dissolved into a solution. So again, saturated solution is any solution that contains as much solute as it possibly can at a given temperature. And if you were to see a chart like this, the saturated solution is the line or this curve. So anything on this curve is considered saturated. So like if I had 200 grams of sugar in water that was at 20 degrees, or if I had water that was at 20 degrees Celsius, I would be able to get 200 grams of sugar into that solution. So anything on the curve is considered saturated. So then how about unsaturated? Well, as we know, the prefix un, like under, means below. So an unsaturated solution is anything that contains less than a saturated solution, so less than the line. So this is a curve for sodium acetate, right? You can see this line. And so any point, any solution that falls below that line, so anywhere in here, would be considered unsaturated. So for example, if we had a solution at 75 degrees and there were 50 grams of sodium acetate in the solution, that'd be considered an unsaturated solution because it's below the line. Okay, so below anywhere on the curve. And then finally, the other type of way that we describe solutions was with the word supersaturated. And a supersaturated, just like Superman, super prefix means that there is more. So a supersaturated solution has more solute than is technically possible. And if you remember, we talked a little bit about this in the last video. The way you make a supersaturated solution is you, for example, take like a solution at 50 degrees Celsius, right? And you heat it, let's say we take it at 100 degrees Celsius, okay? And so we fit about 140 grams of solute into it, and then we cool that solution off. And so as you cool that solution off, you can see where is the arrow now. It is above the line. So as the temperature cools down, there's more solute dissolved than technically possible, and that's how you get a supersaturated solution. So any point that you would have above the line is considered supersaturated, okay? Now, again, remember those three terms are all qualitative. In other words, we can't really do any math with them. So we want to be able to do calculations and make real solutions. So that brought us to describing solutions quantitatively. And again, we do that because it gives us numbers that we can work with in the lab. So last video, we talked about molarity, and you guys did great with that. Remember that molarity is equal to the moles of solute per liters of solution. Today, I want to talk to you about molality and then also mass percent. Okay, so molality is the moles of solute per kilograms of solvent, and mass percent is the amount of grams of solute, so the stuff that's dissolved, per grams of solution. And this is when it's really important that we understand those vocabulary terms, okay? So now is a great time to go ahead and get out your notes again, somewhere that you're going to keep your information for solutions so you have it to reference for quizzes and tests. And you already have molarity written down somewhere. Now we're going to add molality. Okay, so I'm going to turn this off and switch over to my document camera. Okay, and so we're going to talk about molality. Now, remember that molarity is represented with a capital M, right? Molality, hopefully this will work in terms of focusing. Oh, I do not know what is wrong with this thing tonight. Molality is represented with a lowercase italicized m. It's kind of hard to do in print, but it's a lowercase italicized m. Okay, and so molality also involves moles, as the name kind of suggests. Molality is equal to the moles of solute, just like molarity. But the major difference is that it is divided by the kilograms of solvent. So remember, molarity is moles of solute over liters of solution. Molality is moles of solute over kilograms of solvent. And remember that the solvent is usually water. Okay. Just because it's going to come up, I just want to review really quick. Do you remember how to go from grams to kilograms? It's the same way you go from grams to, or I'm sorry, milliliters to liters. You're going to divide by 1,000. Okay, so just a little side note. So molality is equal to the moles of solute divided by the kilograms of solvent. So let's go ahead and get out some example problems. So you have access to a paper that has 2 pages to it. The first page is the molality practice problems, and then the second page is the percent solution practice problems. So get out the molality practice problems. Or get them in front of you so that we can go over the examples. Okay, and we're going to start with example number 1. Okay, and example number 1 says, what is the molality of a solution made from 1.5 moles of sugar and 0.85 kilograms of water? So we're looking for molality. And I'm just going to write a shortened version here of the equation. So molality is going to be equal to the moles divided by the kilograms of water. So when we read our problem, we see that we have 1.5 moles of sugar. Sugar is going to be our solute, because water over here, the 8.5 grams or 0.85 kilograms of water is our solvent. Okay, so this is real easy. We just put 1.5 moles on the top and 0.85 kilograms on the bottom. Sorry, I forgot the kilo part. Here we get out our fancy calculator. 1.5 divided by 0.85, and we get 1.76. And again, we need to put the unit for molality. So the unit for molality is a lowercase italicized m, which is kind of hard to do in your print. So that's why I always do the fancy little tail off the end to kind of set it apart. Okay, so molality, again, very easy, just like molarity, moles of solute divided by kilograms of water. Let's look at example number 2 now. Okay, so example number 2 says calculate the molality of a solution made by dissolving 4.35 grams of, that would be glucose, in 25 grams of water. Okay, so real quick, let's establish what's our solute and our solvent. Water is always going to be our solvent. So this is our solvent, which means that the glucose has to be our solute. Okay, so again, the equation for molality is equal to moles over kilograms of H2O. Now notice in our problem, we don't have the moles of the solute, right? We have the grams of our solute, 4.35 grams. But can you convert that to moles? Sure you can. Very easily, you just do a little unit analysis, right? You need to know the molar mass of the glucose. So 1 mole of glucose has a molar mass of about 180 grams. There's a little bit of a decimal after there, but I'm not going to worry about it. Okay? So we do 4.35 divided by 180, and we get 0.024 moles. All right, well, we've got our moles. Now all we need to do is get our kilograms. Remember that to convert grams to kilograms, you divide by 1,000, right? So divide by 1,000, and it equals 0.025 kilograms. So now we have our kilograms of water. We have our moles of the solute, and we're good to plug it into the equation. So we're going to do 0.024 moles divided by 0.025 kilograms. So we get our calculator out, and we get 0.96. And again, the unit on this is for molality. So we have moles divided by kilograms, so we're going to put a lowercase italicized m. Right? Very, very easy. Very similar to molarity. The only difference is we're using the water instead of the liters of the solution. Okay? All right, let's look at example number 3 for molality. And example number 3 says, here, so we're not confused, I'm going to fold this in half. Example number 3 says, how many grams of sodium chloride are in a 0.31 molal solution? So when you're talking about molality, you say molal. And if it's made with 0.159 kilograms of water. So this problem is very similar to the problem that we did last time, where we were talking about like what's a realistic example of this calculation. So let's say I'm getting ready to do a lab and I need 0.31 molal solution, and I know that I need to use this much water. How many grams of sodium chloride am I going to have to get? Okay, so again, the equation for molality is moles solute over kilograms of water. Now we have the molality and we have the kilograms of water. What we're looking for is our solute, but it did ask for grams. Now, can this give us grams? Not directly, but if we solve for moles first, then we can solve for grams. Okay, so I'm going to plug in my numbers, my 0.311 molal, and I'm going to set that number to equal to X number of moles, because that's what I'm trying to solve for, divided by 0.159 kilograms. Again, remember that this is the minimum amount of work that you need to put on your paper to get full credit. Okay, so you put that on your paper. Now, how do we solve for moles? So we want to get it alone, right? So we're going to do a little cross multiplying. So your number of moles is going to be equal to 0.311 molal times 0.159 kilograms. So 0.311 times 0.159 is 0.049 moles. Now, did that answer the question? Not quite, because it did ask for grams. So what I would do next is take that number of moles and convert it to grams using the molar mass. So 0.049 moles. We know that 1 mole of sodium chloride has a mass of 58.45 grams. Okay, so we're going to do 0.049 times 58.45. And we get 2.86 grams. That's our answer. Okay. So pretty straightforward for molality, right? That is the second way for you to describe a solution using numbers. And then lastly, we have our final way to describe a solution. And the way that you can do that, and remember, as I talked about last time, this is kind of the more common way that you describe solutions like in everyday life. And that's as a percentage. So we call it mass percent. Or some people call it percent solution. You might see either term. Okay. So to calculate the mass percent of a solution, or the percent solution to calculate the percent solution, you're going to take the mass of the solute. You guys remember what the unit for mass is? Grams. Very good. So the mass of the solute divided by the mass of the solution. Again, mass is grams, solution. Now, one thing you really need to remember is that the solution is the solute plus the solvent. So sometimes you're going to have to calculate that in these problems. Remember, the solvent is usually water. So you might have to do a little bit of math to get your solution number. I'll show you what I'm talking about here in a second. And then, of course, that would give you a decimal. So to make it a percentage, you're going to multiply by 100, and then I'll give you your mass percent. Okay? So again, let's check out a couple of examples here. So you'll want to use that same worksheet, but look at the second page that is titled Percent Solutions. And let's check out example number 1. An 800-gram solution of Kool-Aid contains 20 grams of sugar. What is the mass percent of the sugar in this solution? So I want to kind of identify some things. First of all, we have 800 grams of solution, right? And then 20 grams of sugar. And what part of a solution is the sugar? That would be the solute. Okay, so mass percent is equal to the grams of the solute divided by the grams of solution. And then, of course, you multiply by 100. So let's plug in our number. We know that we have 20 grams of solute. We know that we're going to divide that by 800. And then we will multiply by 100, whatever we get. So if I take 20 divided by 800, I get 0.025, and then I'm going to multiply that by 100, and I get my 2.5% solution. Okay, very easy. Probably the hardest thing is to make sure you identify the solute correctly, right? So water is always the solvent. Anything else is going to be your solute. Okay, let's check out example number 2. This is like the kind of problem you would do if you were talking about like a percent solution that's on like an alcohol bottle. So what is the mass percent of ethanol, which is the alcohol that people drink, in a solution made from 35 grams of ethanol and 65 grams of water? So real quick, let's identify our players. Water is always the solvent, always, right? Pure water is the solvent. Ethanol then must be our solute. Okay, so remember, to do mass percent, we need to know our grams of solute over grams of solution, right? Real important right there that you notice that it's the solution. Remember that solution is equal to the solute plus the solvent. So in this problem, it doesn't tell us the mass of the whole solution. It tells us the mass of the two parts. So we're going to have to do a little bit of math to figure that out. Okay. So we start with our grams of solute. I'm just going to write times 100 on here. And we do 35 grams of the ethanol on top. On the bottom, the solution is equal to the solute plus the solvent. Well, we know the solute is 35. Right? And it tells us that the solvent or the water is 65. Okay? It's real important that you put that in parentheses or do the math ahead of time and plug that number in. If you try to do it exactly how it's written without parentheses, you will get a really weird number. And of course, we're going to copy or times that by 100. So 35 plus 65 would be 100. So this is 35 over 100. Now I'm going to show you how I would put this in my calculator. I would do 35 divided, and then I'm going to put those parentheses in there. Divided by 35, the mass of the solute, plus 65, which is the mass of the solvent of the water. So I put that in, careful with my parentheses, and I get 0.35. Then, of course, we multiply it by 100 to get our percentage of 35. So this is equal to 35%. So if I have 35 grams of ethanol and 65 grams of water, I would be dealing with a 35% alcohol-based solution. Okay? Last question, just like our last question on all the other topics, is what happens if you were trying to make a real solution? How do you go about doing those calculations? Okay? So how do I figure out the mass of the solute so that I can make up my solution? Or maybe I'm just curious how much there is. So this is a great real world question that like a lot of people want to know the answer to. The concentration of sugar in a soft drink is measured to be 10.5%. So there's our percent solution. How many grams of sugar are in 125 grams of the drink? So the drink would be everything all mixed together, the water and the carbon dioxide and the sugar and all that. So this 125 grams of the drink is going to be our solution. And then the grams of sugar or the solute, what we're looking for, that's our unknown in this case. Okay? So we're going to plug everything into that equation for calculating mass percent. We know that the percentage is 10.5. And we know that that is equal to, let's see here. That is equal to the mass of the sugar, which we don't know. So the grams of the sugar divided by the grams of the solution. So that would be 125 grams in this case. And then, of course, you have to take that number and multiply it by 100. So we plug in what we know to our equation, and so we're left with what we need to solve for. First thing we want to do is get rid of that 100. So if we're going to multiply by 100 here, we want to divide by 100 over here so we can get rid of it. So I'm left with 0.105 being equal to some mass of sugar divided by 125 grams of water, the solvent. Now, how do I solve this? My unknown is over here. Just like we did before, you're going to do a little cross multiplying, right? Do a little cross multiplying. And we get for an answer, we're going to take 125 times 0.105. And we get 13.13 grams. So in order to have a 10.5% solution, right, sugar solution, if I have 125 grams of my soda, that means that I would be dealing with 13 grams of sugar. Okay? So those are the two new things that you need to know from here on out, how to calculate molality and how to calculate mass percent. So now that we have done both, you need to go and do those practice problems on your own. So on the molality side of the page, you'll see that there's the 3 example problems we just did, and then problems 4 through 8, which is just 5 questions that I need you to do. And then on the percent solution side, same idea. There's the 3 questions that we just did together. Then you have 4 through 8, so just 5 problems that you need to do for mass percent. So today's homework, or whatever you want to call it, practice, is to complete 10 problems, 5 molality and 5 mass percent. Okay? All right. I think that's it. Go ahead and practice away.